All right, so let's see what we have in store for polynomials. Oh, you know what? I think I have a sheet for you. Let's see. No. There's you could, hey, you could, thank you. Oh, they're for them. Thank you. Okay, everybody, let's take a little look-see-loo at what I gave you here. So you probably remember a whole bunch of this. So I'm just going to breeze through this real quick and we'll see where we end up next. So remember the term polynomial? That is just our umbrella term for, hey, this is a mathematical expression and it has multiple terms put together using addition and subtraction. All right, well, what in the world is a term? A term is a number, variable, or a product of a number or variable. So if you take a look at these examples that I've given you, each of these represents one term. That's one term. Even this is just one term.
Aren't they separated by like addition?
A polynomial would be, yep. So
Like
each of these,
though.
yes. So wherever you have a plus or a minus, that would indicate a break between your terms. So even just a single number by itself, a constant, that's still just one term. All of these individually are just one term. Okay, even though they might have multiple variables, it doesn't matter. It doesn't matter if it's a number, a variable, or a product of numbers and variables, that whole thing counts as one term. So if you look down here, I've given you a bunch of examples of two-term polynomials. We have a 3x plus 5y. So there's my first term, there's the second term, two terms altogether. Same thing here. It doesn't really matter. It just matters. See how I have a minus that sort of breaks the two apart? So this would count as two terms. Even this would count as two terms. So all of those are two-term polynomials. I call them chunks. You can call them whatever you like, but the proper name is terms. So now we're just going to name our polynomials based on how many terms they have. So if you take a look at this handy little chart that I made for you, you probably remember this from Algebra 1. Monomial, that prefix mono meaning one. So here are three examples of one-term polynomials. And then we've been throwing around the word binomial quite a bit. Binomial, prefix bi meaning two. You have two terms in each of these polynomials. And trinomial obviously means three, tri meaning three. We have three terms in those. Now, what if you have more than that? We just say a four-term polynomial, a 10-term polynomial. So the three that you need to know though are monomial, binomial, and trinomial. Make sense so far? So let me give you a random one and you tell me how many terms that has. What if I gave you something like how many terms does that thing have? Three. So it would be called a Hello, a trinomial. Thank you so much. Maddie, for you. Okay, trinomial. Let me try and trick you. What about, oh yeah, so trinomial. Isn't it weird to write? Have you not written in a long time? Yeah, it's weird for me. Anyway, what about this one? What would that be? A binomial. I have two terms. Binomial. What would this one be?
No, binomial.
Yes. So if your first instinct was trinomial, I can understand why. But this one is actually just not simplified yet. I should simplify as much as I can first and then sort of identify from there. I have like terms right here. So if I combine them, this expression is really negative 2x squared plus 1. And then it's clear to see, oh yeah, that's a binomial. Okay, easy peasy?
Wait,
Yeah.
so what if you have a trinomial or like something that's like, I don't know, like 4x y plus x plus, I don't know, like 1 or something. What do you do with the x? Can you like add it to the other x?
No, good question. So these, oh, sorry. These are not actually like terms. The 4xy plus x, not like terms. It has to be the exact same variables, raised to the same power too. So if it's not the exact same variables raised to the exact same powers, I can't do anything. They're not actually like terms. The only thing you could do with this thing, but I don't know why you would, you could factor an x out of the first two, but it's not going to help you any. So
Okay.
I would not bother. Yeah, so that is still a trinomial. That was a good example. All right, so is everybody comfortable naming monomial, binomial, and trinomial? And then more than that, you just say 4-term, 5-term, 6-term, whatever it is. Yeah, okay. Now let's talk about the degree of a polynomial. So if we take a look right down here, we have our little definition. So the degree of a polynomial is the highest exponent of a variable of any term. So, and you want to be careful because sometimes we don't write them in order. We should. It's a good habit to get into. But you always want to look down the whole line. And the highest exponent I have in this case is 4. So the degree of this polynomial would be 4. They do have special names, which I think I put on the back. Yeah, they're on the back. So highest degree of that one would be a 4. And then if I look at this example, oh, the highest one I have is a 6. Now, what do you do when you have more than one variable, right? Like, what do I do? I have an example here. I kind of hole punched it out, sorry, but if you look right there, you can probably see it. 5x y to the 4th z to the 3rd. If you're trying to figure out the degree of this thing and it has multiple variables, guess what you do with the exponents?
Add them or multiply?
You add them. So you would add all of the exponents together, and that would be the degree of the entire term. Isn't that neat? So the x really has an exponent of 1, doesn't it? So I'd have 1 plus 4 plus 3. So the degree of this entire thing would be 8. Does that make sense? Okay. All right. So,
So you have to count the 1 for the x?
yes.
Okay.
What if, oh, see, this is past me wrote this, and I was just going to give you an example like this, and it's already right here. If I ask you about 17, what's the degree of 17? Don't read the words, just guess. What do you think it is?
1.
I know why you would think it's 1, but it's actually not. Remember, the degree is the exponent on the variable.
There's no variable.
There's no variable. So that means if there were a variable, it would have had to have been to the 0 power. Because what's anything to the 0 power? Do you remember?
0. 1.
1. So the degree of this thing is just 0. So if you have a constant That's just a number, no variables. The degree of that thing is 0, and we call it a constant. All right, let's take a look-see-loo at the back. The back has the chart of the names for all the thingies. So you have, so we were just talking about this. So if it's just a number, the degree is 0, it's called a constant. Why is it called a constant? Because it's the same. It doesn't change. It doesn't vary like a variable. Oh my gosh, it's almost as if these words were chosen with meaning, because they are. A variable can vary. It could be 1 in one problem. It could be 10 in another problem. You can change it. But constants don't change, do they? No, 5 is always 5. Anywho, so there's that one. If you have something just to the first power, we call it linear. Why? Why do you think it's called linear?
Because it makes a straight line.
Exactly. If you graph y equals 2x, it's just a straight line, my friends. Linear. That's when I have my highest exponent. The whole thing is just a 1. Quadratics, we just did a whole chapter on those. That's just your highest exponent is a 2. Quadratics, you know what those look like if you graph them. They are a, yes, a U shape or a parabola. Yes. The next one is our cubic function. That's your highest exponent is a 3. Cubic, I don't know if you remember, but those are the ones that look like this. Quartic. Quartic, that's a 4th degree polynomial. So quartic, these graphs, we're going to be talking more about the graphs later on in the chapter, but they kind of, sometimes they can look like a W. Isn't that neat? And then quintic would be 5th degree. Those can look like that. And then it goes on forever, right? You could have 6th degree, 7th degree, and so on. But you do want to be familiar with at least up to a 5th degree. So these words, constant, linear, quadratic, cubic, quartic, and quintic. Most of them make sense. I just don't, I hate how 2 is quadratic because I know quad, you think 4, but I don't know why it is that way. Why is it not a biradic? I don't know. Why'd they go quadratic? I couldn't tell you. I don't know that answer. Sometimes math makes so much sense, and then sometimes it's like, hey, let's just mess with you. Right? Isn't that weird? I don't know. I don't know. Ah, anywho, we've been talking throughout the entire course about writing things in standard form. So that's just when you are going to rewrite. Well, first you're going to combine any like terms if you have any, and then you just write it with the highest exponent first and then work your way down. So if you take a look, I have some examples for you to try. You take a look right here. Go ahead and rewrite that thing in standard form. And then I also want you to try and name it. So rewrite it in standard form and then name it by number of terms and its degree. So you'd pick one from the list on the front side, one from the list on the back side. Give it a try. So you're doing 3 things. You're rewriting it in standard form. You are naming that thing by the number of terms it has. So monomial, binomial, trinomial, or whatever. And then you're also going to name it by degree. Is it a constant, linear, quadratic, cubic, quartic, or quintic, or something else? I don't know. Also, when you're naming, usually we do the degree name first and then the number of terms. So for example, if it's a linear binomial, we say linear binomial, not a binomial linear. Okay, so for this one, how do I rewrite this in standard form? What's got to come first? Yes, negative 2x cubed followed by. Yes, keep going. Perfect. I don't have any like terms here, so that's the best I can do. And then I'm going to name this, I actually want to do the degree first. So if I'm going to name this by degree, it'd be called a, oh, someone said it, say louder. Cubic, because the highest exponent's a 3. So this is a cubic. And then if I name it based on number of terms, it's a 4-term polynomial. Cubic 4-term polynomial. If you feel like writing the whole thing out, which I don't.
We just put 4 poly.
I mean, I guess. This one, if I put it in standard form, should I call on you at random?
No.
It's been a while, and these are easy. Ish, right? Yeah. Ah. Okay. Sam, what is this in standard form?
4x to the 5th minus x to the 4th plus 3x to the 3rd.
You are correct. If I had to name this thing by degree, Jill, what would this be by degree?
Like, do you want me to say the full name or just like?
Just the first word.
Quintic.
Yes, quintic, because the 5th degree is the highest one we have. Quintic, and then by number of terms, Nathan, it would be a? Yes, so quintic trinomial. Easy peasy. Now, this one is already in standard form. There's nothing else to do. If you had to name this by degree, it would be Brady A constant. And then by number of terms, it would be what? Adam B. Well, you have, so your degree is actually 0 because it's just a number. So we have constant, but how many terms is this? Is it 1 term, 2 term, 3 terms? Monomial, yeah, so constant monomial for just a number, right? Isn't it funny that its name is so long, but it's such a short little number? Anyway, the last one, 33 plus 2x. Angelina, what is that thing in standard form? Of course, we have to swap them around. By degree, that thing, Ethan, will be called a? Yes, linear. And then by number of terms, Jeff, it would be a? Correct, binomial. All right, easy peasy. We can name, reorder. We know what degree is, terms, polynomial, all that fun stuff. Okay, great, because now we're going to do operations on these polynomials. So you already know how to do this. I know you already know that you combine like terms. I know you already know how to multiply. You know how to FOIL. We've been FOILing for forever. I know it. You know how to multiply a binomial times a trinomial, right? Do you? Yeah. You just take the first term, multiply by all 3, and then the second term, multiply by all 3. If you have a 3 by 3, a trinomial times a trinomial, you just got to do the same thing. You do the first term, multiply by all 3, the middle term by all 3, the last one by all 3, and then combine like terms. Easy peasy. Shall we try some? I thought you'd never ask. Just kidding. I knew you were going to ask. That's why, before we even left for break, I made copies for us.
How sweet.
Right? Just thinking ahead here. My goal is to have all the photocopies done for the rest of the year, soonish. Not there yet, yeah. Go so fast, oh my gosh. It's always a good idea to get those copies done early. What if they break again? What if? I don't want you guys to go without. But now. It's a win-win. Problem is, I don't always know what I want to do yet. So I have to feel like a mind reader. I love your phone case. I was like snorkeling with teachers. So cool. Okay, let us, everybody has this sheet now. Let's go ahead and jump down to, yes, Jeff. Please. My day wouldn't be complete. All right, what am I doing? Number 11, but I swear, all my good pencils just get stolen. All right, whatever. So let's take a look at number 11 here. So here, all you're doing is you have to do the operation that is indicated. So on number 11, notice everybody that we are subtracting these two. When you are subtracting, you need to make sure that you are subtracting the entire second thing that's in parentheses there. So you really need to distribute that negative sign, and then we can just combine like terms. So it's actually a lot easier than you think. I always laugh when I give the test on this to see how many kids see a problem like number 11 and they multiply it. Like, oh my gosh, you just did so much work.
You multiply the -1 to the second thing.
Right. But some kids, I don't know, they gloss over the fact that there's a minus sign between these two things.
That's why I multiply it by -1.
Mm-hmm.
So you still multiply.
So my first chunk of numbers really doesn't change.
Oh, this is my
But now I need to distribute that negative throughout this whole thing. So I have a minus k to the third, minus 3k, and now a plus 8. To finish this problem off now, I literally just have to combine like terms, and I'm basically done. Oh, and then they want me to name the answer, but that's no big deal. So here's how I do it so that I always have my answer in standard form at the end, and I don't add another step. Just start with your highest exponent. Oh, the third. And look, you have 7 and a -1. So if you put those together, isn't that going to be a 6k to the third? Then I just work my way down the exponent. So I did the thirds. Okay, squareds. Oh, there are no squareds. Okay, move down to the first. -6 and a -3. It's going to be a -9k. Those are done. And then I move, the last thing I do is the constants. A -5 and a +8 leaves me with a +3. There is my answer. Wasn't that easy? Just combine my terms. They do want me to name this thing. So if you had to name it based on degree and number of terms, it would be called a, yes, a cubic trinomial. Cubic because my highest exponent's a 3. Trinomial because I have 3 terms. Cubic trinomial. Okay, you try number, you try 13. Same idea. It's another subtraction problem. So just distribute that negative. And then combine like terms. Easy peasy. Okay, you got it? Remember that first chunk of numbers really doesn't change, but then I'm going to distribute that negative. Negative 6x to the fourth plus 6x squared plus 7x. And then when you combine like terms, does anybody have what the answer is going to be? Go ahead.
3x to the fourth plus 7x.
Oh yeah, okay. Oh yeah, because those 7x's canceled. Oh, how lovely. So there it is. And then if I'm going to name that thing based on degree and number of terms, it would be a
Oh wait,
No,
quartic.
quartic. What's the second word? Binomial. Yes. Quartic binomial. Now, don't get messed up when it's addition, like 15. When it's addition, your life's even easier. You know, there's no negative to distribute. So you can literally just combine like terms. You don't even have to rewrite it. I don't bother. I basically am just ignoring the parentheses. I'm just going to combine like terms. X to the fourth and another x to the fourth. Isn't that 2x to the fourths? And then I don't have a to the third. I don't have a squared. So then I go all the way down to the first. A -8 and a +3 is a -5x. And then my constants at the end, +3. And see how if you do it that way, your answer will always be in standard form automatically. You don't then have to like rewrite it. And now it's easy peasy. And I can name this thing by degree and number of terms. What would this be? Quartic trinomial. Isn't this simple?
Yeah.
Okay, and then I know you know how to FOIL. So let's try one where it's a, let's try something like 22. Let's just make sure we can all multiply a binomial times a trinomial. 22 we're going to try. So me personally, I just take the first term, k in this case, and I multiply it by all 3 of these. And then I take the -1 and I multiply by all 3 of these. So I get one big long string of 6 terms, because 2 times 3 gets me 6 thingies. And then I combine whatever like terms I have. So my answer could have less than 6 terms. But when I first do it, that's actually a nice way to check, especially when you're doing like a 3 by 3. Sometimes it's easy to miss one. So if I know, okay, I have a trinomial times a trinomial, I should have 9 thingies before I combine like terms. So here I should have 6 thingies before I combine like terms. Okay. We have an answer? I have no idea what it is, so even if you tell me, I won't know if it's right. But let's find out. Let's check ourselves together. So I'm basically going to do k times all three of these. Right? So when I do that, I'm going to get 2k to the third plus 5k squared minus 2k. Then I have to do -1 times all of these things. So right in the same line, I just keep going. Minus 2k squared, minus 5k, and now a plus 2. So, and then I'd like to just double check. Do I have 6 terms? 1, 2, 3, 4, 5, 6. Yep. Okay, cool. Now I'm just going to combine. Oops, I didn't realize I was off a little bit. I'm just going to combine like terms, just like I was before. So my highest exponent is a 3. I don't have any others. So 2k to the third will just stay. And I go down to the squareds. Plus 5 minus 2 plus 3. Squareds are done. Then just the k's, -7k. And then a plus 2 on the end. Did you get what I got?
Yeah.
Yay. Okay, let me try and trick you. Try number 26, please. 26, everybody. Everybody. Try 26. Pencil to the paper and actually try it. Don't just try it in your head. Write it down. Because I'm hoping that if you write it down, you'll be less likely to make this super common mistake. It's going to mess you up if you don't get a handle on it pretty quick. So let me just say this. If your final answer is a binomial, you're doing it wrong. You are doing it wrong. And I don't want you to do it wrong anymore. We're going to fix this once and for all. What you should have done with number 26. You can't just square both of these things and call it a day. Oh, you cannot do that. Why? Because that thing on the inside is a binomial. If it were one term, you could do that. If you're raising one term to a power, then yeah, give everything in there, that exponent, and life is fine and dandy. When it's a binomial that you're squaring or a trinomial or anything else, you have to multiply it out. So you're actually doing 1 plus 5m times another 1 plus 5m. So if you did not FOIL this, you're going to get it wrong every time. So first, outside plus 5m, inside plus 5m, and then the last would be a 25m squared. When I rewrite this and combine like terms and put it all together, I get 25m squared plus 10m plus 1. There we have it. There is a pattern. If you are a pattern person, you use the pattern, that's fine. But all I care about is that you know that this thing turns into this lovely trinomial. So be careful. When you have a polynomial squared, you got to multiply it all out like that. How are we feeling so far? I just have one more little thing left to talk to you about, and that's it. Do you know how to divide a polynomial by a monomial?
Yeah.
Ooh. So if you take a little look-see-loo at number 1 on the back, let's say. When you are dividing a polynomial such as this by a monomial, right? This thing is a monomial. That's only one term.
Do you have to simplify or factor the top one and you put that at the bottom and then you like factor it? And then you can
So you can, but you don't have to. If I'm dividing by a monomial, my life is actually super easy because all I have to do is come in here and I'm just going to divide I'm dividing the whole thing by 8n squared. So I sometimes like to write it just dividing each one of them by 8n squared. It's the same, if you do one big bar, it's the same idea. But check out what's going on. If I just, let me just zoom in on this. Just look at this first fraction, forget the others. Let me write that 8 so it actually looks like an 8 and not a 6. So ignore these other fractions for just, oh, you can't even see them. There we go. So ignore these other fractions. See how I have 40n to the third over 8n squared? Just look at that one fraction. I can simplify just that fraction. What's 40 divided by 8? 5. And what happens? Oh, yes, you just subtract. Oh. So what's going on with the, I keep doing that. So I'm thinking that the lead's like falling back in the pencil. It's not, I'm just writing over the hole there. So my pencil's like literally going into the paper, but I thought, anyway, you don't care. Let me shut up and move on. There we go. That's better. Now I won't write in the hole. Okay, so 40 divided by 8 is just 5. And then when you're dealing with variables, you just subtract the exponents. So 3 minus 2 is just n to the first. So that's literally this whole first chunk divided. My answer is just 5n. And then I do the same thing for the next one. 32 divided by 8 is just 4. And then the n squared over n squared just cancels. And then this one's a little weird, right? Because look at what's going to happen. I do have 16 divided by 8 is 2, but look at the ends. What are you going to have left with the ends? Yeah, you have an n in the denominator. So this one, I do have 2 because 16 divided by 8 is 2, but I have an n in the denominator. Does that make sense? That's a little weird, but there you have it. I'm basically just simplifying that fraction. I'd have a 2 on top and I'd have 1 n left in the denominator. And that's my answer. This whole thing, there is my answer to that. If I can't reduce the fraction, or I'm sorry, if the numbers don't divide, then just leave the fraction as it is. So let's try number 2 together. This one's a little bit different. So number 2, I'm sorry for the bad printing job, but you take what you can get, right? So we're dividing by 9p. So that's a division symbol, if you can't tell. So again, that's a monomial. Tomorrow, we will be dividing by binomials and trinomials. Oh, and for that, I don't think you did that in Algebra 1. I don't know if you did this in Algebra 1, the dividing part. Maybe you did.
We did.
I don't remember. But divided by a monomial, very easy, right? So we're going to sneak in and we're going to divide each of these by 9p. So I basically just have these 3 fractions that really all I'm doing is simplifying. So my first one, what comes out of that? If you simplify 9p to the third over 9p,
P squared.
just p squared, right? The 9's cancel. And then 3 minus 1, I get p squared. Is everybody okay so far?
Yeah.
All right, now look at the next one. Now this, it's not quite as clean, right? Because it does reduce down to be 1/3, but all the other ones, it was just like some nice number. That's okay. You know what? Sometimes it's just going to stay a fraction. So if I reduce 3 over 9, I get 1/3. What's going to happen with the p's?
There's going to be 1 on the top.
Yes, I have 1 p on the top.
Can you just put p over 3?
You can. And now what happens with this third fraction? Oh,
2/9.
it's just 2/9. The p's cancel and I just leave the fraction. That's as best as I can do, right? And there's my answer. So I'm just simplifying each little mini fraction. Make sure you watch the signs, right? If any of them were a negative, I would have left it negative, etc., etc. Is that so bad? You try 3 without me telling you what to do. Again, sorry for that's a 4 right there. That first exponent's a 4. That's a 2. And you are dividing by 4b. I think the rest of it, 4b squared, excuse me. The rest of it is legible enough. Okay. Who thinks they have it? Sam, go ahead.
B squared over 2 plus 5b plus 1/2. I don't know if it's right.
It sounds right. I have no idea what the answer is, but what you said sounds very good. So I'm going to divide everything by a 4b squared. So that first one, you said b squared over 2?
Yeah.
I agree. B squared over 2 for that first fraction. And then what was your middle one?
5b.
5b, perfect. And then the last one,
1/2.
that's it. Oh, I'm so sorry. I didn't realize I was off. You guys never told me.
I wasn't off. Oh, wait.
I
yeah,
was.
that
My answer was off. What are my YouTube fans gonna say?
I don't know. Why don't you ask them?
Yeah. Crickets. So, thoughts? No thoughts?
It's all right.
It's all right. Tomorrow, I can't wait to show you long division with polynomials. Did you even think that that was a thing? No, why would you? It's a thing.
I was hoping it wasn't a thing.
It is, and you're actually really gonna like it. I have a feeling. And maybe, do we get to synthetic division tomorrow? I don't remember. Maybe. I'll have to check my list. Oh my gosh, wait till you see synthetic division. Then you'll really be like, wow.
Let's see.
Can't wait. All right, so let's see what we should do for our homework tonight. How about all right, let's do this. So on the front side for your homework this evening, could you please do the following? I want you to fill in the chart at the top, and then let's do the rest of the evens on the front. So all of the chart. So fill in chart, and then the rest of the evens. Please feel free to use another sheet of paper. There is not a ton of room on here.
And the evens?
Evens on front. Plus number 4 on the back. You don't have to send a separate picture of number 4 on the back. But I just want you to try it before tomorrow. Okay? So you can just send me a picture of the front of the worksheet or whatever work it is that you do on a separate sheet, whatever. Okay. Does anybody have any questions right now? We feel all right? Do you know how to fill in the chart? Figure it out? I'll do the first one. Why not? Just like you like that. I don't know what you want me to put here. So if something is degree 0, it's named based on having a degree 0. Yep.
So evens across the entire field.
Yes. So if you have degree 0, that is called a constant. And here's an example of such a constant. And then the number of terms that this example has is just 1. So if I were to name something that has one term, that's called a monomial. So that's all I'm looking for. Get what I mean, Jelly Bean? I'll do the second one. Why not? What the hey? Should I just do all of them? No, I'm just kidding. Oh my God. But if I have something that's to the first degree, remember that's linear. You can refer to that chart if you don't remember. So here's an example of such a linear thing. How many terms does this example have? 2. So that would be called a binomial. Okay, so that's it for the chart. And then go ahead and try the rest of the evens on the front plus number 4 on the back. Let me know if you have any questions. I will open this on Jupyter in just a moment. Yes. Yep, the next one down is another binomial. Does everybody have what they need from the thingy on the screen so I can put it away? Okay, I'll take that as a yes. Good, good.